and welcome. This is Aurora with Supercharged Science, Homeschool Science Curriculum and programs for K through 12. And today we are going to be doing a really cool project. Let me show you. We are going to be baking solar cookies. I'm going to show you how you can make this project easily and just using everyday materials. So if you've joined me before, you know how this goes. We are going to be doing a project together. I'm going to give you some content. We'll be together for maybe 30, 40-ish minutes. And at the end of class, or if you still have questions, you can always send me an email, aurora@superchargedscience.com. If you would like a shout out right now, make sure you type in your name and where you're from, and I can say good morning and hello to you. And I am so excited to be sharing information about our summer camp. So if you guys have been enjoying, if your family, your kids have been enjoying our content, our classes, we're getting ready to release our summer camp, and you can be one of the first people to enroll in it. You see this link down here? Go ahead and take a screenshot of that. Go ahead and just open it up in a new browser. We haven't actually, a camp will open on June 1st, but you can reserve your spot now. So you can learn all about that summer camp right there. So we will be doing a full-blown summer science camp where your kids don't even have to travel. Everything happens at home, and it's very similar to what we've been doing with Facebook Lives, only your kids will be able to navigate and do a ton of projects and experiments all right at home, stay happily engaged, learning all summer, won't even feel like education because it'll be so much fun. So at the end of class, I'm going to demo that for you, and I'll show you the different projects, the flashlight laser tag, the rockets, the lasers, the go-karts, all the stuff that's in a summer, all the fun that a summer should be, all packed into a camp that you can do at home. Okay, so let me go ahead and get started with my hellos. We have hello to Amy and Alyssa from Florida, and we have India from in the UK. We have Liam. We have Raj from Colorado, Braden from Virginia. Hello. We got Lauren and Natalie from Washington, and Hannah and Daniel also from Washington. And we also have some folks from California. Gosh, oh, we have a lot of families from California. So hello, from Paso to Atascadero to San Luis Obispo to Carmel to Sacramento. We also have Brooke and Gavin from Oregon. Hello. We have Gabriel, Maddie, and Cole from Colorado. Good morning. We have Lizette from Cape Coral in Florida. I know we have a couple of families from Kenya as well as South Africa, so I want to extend a special welcome to you. We also have a number of families that are tuning in from France as well as from Germany, and with the request has been talk slower so we can figure out what you're saying. So good morning and hello to all of you. We have Grace from Mississippi. And Allie is excited about solar cookies. Please don't eat all of your dough. Save some of it for the cookie project. So don't eat all the cookie dough right now. Just put a little cover on it if you're too tempted. So just put it aside. Okay, and we have Oliver, Emery, and Sully. Welcome. All right, are you guys ready? If you are, say, oh yeah. Okay, so today we are this week is renewable energy. What does that mean? We're going to talk about that. We've done batteries. We've also taken a look at how salt can store energy. That was yesterday's project, which I got a number of kudos from saying that was amazing. Thank you so much. It's funny because that was the one project I was on the fence about. I'm like, oh, it doesn't seem interesting enough, or maybe it's a little too hard. And I almost didn't include it. But a number of families said that was my favorite so far out of all of them. And I'm like, really? Out of rockets and catapults and lasers, that was your favorite? Okay. So I'm glad I included it. Okay. So we also have a family from Vancouver Island, so welcome, and a family from London. Hello, welcome everyone. So my name is Aurora with Supercharged Science. We are going to be doing a hands-on class in renewable and alternative energy. If you don't have any materials at all, don't worry, just grab a pencil, a piece of paper, and jot down the experiment of what we're going for. And then when we're done with today's class, look around and see what you can use. So it's very simple. Now, before I forget, tomorrow we are going to roast marshmallows. We're going to roast anything that you've got on hand. Hot dogs, you could roast anything. And it turns out, I didn't actually do this, but I understand from students, you can melt pennies with the experiment from tomorrow. So tomorrow's experiment is very, very energetic. You do need one thing though, And if I reach back here, maybe I can find it. It's one of these. I got mine from the dollar store. It's a Fresnel lens. Now, you can't use a magnifying lens for tomorrow, like a handheld magnifier. That won't work. You actually need one of these little cheap Fresnel lenses. You can get them from Amazon. You can get them for like a couple bucks. And they are smooth on one side, and listen to this. Ooh, right? And rough and bumpy on the other. There are thousands of little prisms in here. This is what you're going to need tomorrow, because we are going to be making basically a lighthouse for our food items. And so just make sure you go find one of these for tomorrow. If you don't have one, don't worry. Just like I always say, just follow the instructions, and then when you get your stuff, you'll know what to do. Okay, so that was just a quick shout out there. And so, by the way, if you've just joined us, that link at the bottom, the registration for summer camp, which starts June 1st, is now open. Shh. Tell as many people as you can. And so this is the link that you can access it and find out more information. So make sure you jot that link down as well. Okay, so let's go ahead and get started. Oh, we have families from Ontario and Minnesota. Hello. All right, let's go ahead and get started. I'm going to set up my slides. You are going to tell me what alternative energy is and what renewable energy is, and if there's a difference between the two. Type it in, tell me out loud, pretend I can totally hear you. Just shout out the answers. Well, if there's people around you, don't shout. We want them to let you, see me again and again, so make sure they don't get too upset. Just tell me out loud. Pretend I can totally hear you. We're having a conversation about real science. Now, by the way, the comment box, feel free to type me any questions at all during this class. Do keep it on topic so you don't get kicked permanently out of Supercharged Science. We have to keep it family friendly and nice and kind. And so actually, it's just a way for you to communicate with me. You're not talking to other people's kids. You're just talking to me. So go ahead and type in the answer if you want to, or just shout it out. You don't have to type. Just tell me, what is renewable energy, what is alternative energy, and what's the difference between the two? Go ahead. I'll give you about 10, 15 seconds. I'm going to set up my slides while you do that. Go for it. Ready, set, go. Keep going. I'm almost there. I'm still getting my slides up. Hang on. It's a little bit slow today. Keep going. Keep going. What is alternative energy? What is renewable? And what's the difference? A lot of people use these two terms interchangeably to mean the same thing, but are they really the same? Go ahead. You got about 10 more seconds. I'll give you 10 more. Okay. So since this is a new area of science, it hasn't been well defined, but as close as I can find it now, this is how people are officially defining these terms. Renewable energy is generated from natural processes that are continuously replenished. So you're going to find renewable energy is sunlight, geothermal heat, wind, the tides from oceans, water, various forms of biomass, fuel from cornfields. Now this energy cannot be exhausted because it's constantly being renewed. Like you're never going to run out of wind, right? Sometimes people wish the wind would stop, but it doesn't. So that would be renewable. Alternative energy is what people mean when they say that is an alternative to fossil fuels. Generally, it indicates energies that are non-traditional and have a low environmental impact. So this term alternative means to contrast it with fossil fuels for different sources. Now, by most definitions, alternative energy is a type of energy that doesn't harm the environment. And that is what separates it from renewable energy, which may or may not have a significant environmental impact. So alternative is not a big impact to the environment. Renewable is not, it's inexhaustible, okay? So does that kind of make sense? All right, so both those words though have one similar word, right? Renewable energy, alternative energy. Okay, so what is energy? So energy is the mover and shaker of the universe. Heat from the sun, sound from your radio, riding a bike, watching a movie, those are all expressions of different forms of energy. As you sit here listening to me, there is energy flowing all around you. Light waves, sound waves, radio waves, heat, you name it. So you are constantly being bombarded with energy. Most of that energy you're not going to be able to see with your eyes. Now, energy has a number of different forms. I put them on the slide there. There's kinetic, that's the moving energy. Potential, that's the could energy. That's like you put a ball in the hill and it's not moving yet, but it could roll down the hill. That's potential energy. Or you take a spring and you put it together and you compress it. It hasn't done any work yet, but it could, right? That's the could energy. There's also thermal energy. So thermal temperature, chemical energy, that's like the energy locked up in atomic bonds in molecules and atoms. Electrical energy, sound, electrochemical, electromagnetic, nuclear. We could go on and on and on. There's a lot of different forms of energy. And all energy that we have available on the earth comes from one source. Do you know what it is? It comes from the sun. So when sun falls on the trees and the grass, they use that to make chemical energy, which is used later for other things, right? That energy is transferred to the animals that eat the plants, right? Okay. Now, you could also argue like, hey, wait, there's some energy that's deep inside the core that we can access. Well, we can't really go down to the core of the earth yet. So for our conversation, energy that is on the planet, 99% of it comes from the sun. Okay. So moving along. So let's start at the top. Energy comes from the sun. We get solar power from the sun directly, right? But the sun also drives the weather in the atmosphere, which also means the sun is responsible for wind. It's responsible for waves and tidal energy. The wind causes the waves in the ocean. The sun's gravitational pull, along with the moon's, causes tides and waves on the oceans. Okay, so let's take a look at the sun specifically. Once the sunlight hits the earth, how do we use it? How do we use it? Say it out loud. How can we use this light? If we're talking about alternative energy and renewable energy, what's the first thing you think of? Right. Okay. Maybe wind turbines, maybe solar cells, right? Okay. So why would you bother with these types of energy anyway? Why would you care? Well, for one thing, on an ongoing basis, after you've installed these things, these are less expensive. A house on solar energy can get free electricity if it's got solar panels, right? Or you could be paying a couple of $100s to over $1,000 a month for utility bills, gas, electric, and that sort of thing, okay? And if you made like a solar powered toy, you'd never have to replace the batteries in that toy, right? You just put it out in the sun, it'll recharge and there. Okay, what about if I was a satellite in space? Would I have to take my energy source with me? The batteries are usually like the heaviest part of the satellite. No, if I had solar panels, I'd open them up, point them towards the sun. Now I've got energy, right? So it's really useful to be doing this. Okay, so when you see solar panels on a house, they could be doing one of two things. They can heat water or they can generate electricity, and it can be difficult to tell the difference between the two, whether this one in the house is heating up water or whether it's producing electricity directly. So what happens is if we take these panels off, if it's heating up water, you'll see these tubes going up and down, up and down, up and down, and they run water through this. And so what happens is those solar cells will be concentrating that light from the sun and putting it into the water. And so cold water comes in, but when it's done with this little zigzag underneath the solar cells, it'll actually be hot water. And you can use that for like doing the dishes or doing the laundry or taking a hot bath or shower, that kind of thing. So the other way solar cells generate the other way is, I think I have a slide here. Solar cells can convert sunlight straight into electricity. So those are also called photovoltaic cells, and they are used to make electricity from sunlight. So when you shine the sunlight on them, they just make electricity. So you can use them anywhere you've got batteries. So solar cells are typically made of an element called silicon. So when light hits a solar cell, it knocks electrons off of their shell, off of their atom. And now you've got these naked electrons, these free electrons that are free to fly around. And if you can force those electrons only in one direction, now we have a flow of electrons, which is what electricity is. We have charge. Now we have a DC current. So this is just one of the neat properties of silicon. By the way, silicon is not the only material to do this, but that's basically how they work. Now usually solar cells have two little wires coming out, and you can use that electricity that they generate for anything you'd normally use batteries for or electricity for, right? You can power the outlets in your wall, you can recharge the batteries in your car. Once you have the panels installed, how much do you think it would be to run your household for all the electricity stuff that you need? Yeah, it's like zero, right? But you got to get them installed first. So typically the panels will last like 20 to 30 years or more, and you do have to clean the dust off every so often. And so this is the reason so many countries have been moving to solar cells. Solar cells are made though in a factory even though the solar cells when they're in use don't cause pollution, the factories that make the solar cells actually do cause pollution in the atmosphere. So they're currently working on that process to make it even cleaner. Now the cool part about this type of energy is that it's free, right, when it's available. But what's the problem? Can you tell me what the problem is with solar cells besides being expensive? What's the problem weather-wise? Okay, how well would they work if you live in a place where it's not sunny? Yeah, if it rains a lot and it's overcast a lot. Now, do solar cells work at nighttime? They don't, do they? Okay, so a lot of the panels are big. Look at the size of the guy, right? This is actually kind of a small panel. They're expensive and they require a factory the size of your neighborhood to make them, right? So it may seem like, well, it requires a lot, maybe for a seemingly little output, right? For the benefit. So there was a company that wanted to make they wanted to make this huge solar panel plant, and they wanted to put thousands and thousands of solar panels and hook them all up together and make a huge power plant. But they quickly figured out that if they decided to do this, here, look at the guys again, if they were going to do thousands of these things, they found out, ooh, it's actually really expensive and it doesn't work quite as well as we thought it did. Let me give you a hint as to what they did. If I show you the next picture, can you tell me out loud what it makes you think of? What does this make you think of? You ever done this experiment where you take a magnifier and you set something on fire? Okay, you ever concentrated the sun's energy through something like a magnifier? What happens? Right, this is why you should never look at the sun through anything with lenses. This is what happens to the back of your eye when you look at the sun through anything, binoculars, telescopes, anything with lenses, and you look at the sun. Yeah, yikes, right? So you will go permanently blind. Okay, seriously though, this is, so we're concentrating the power of the sun using a giant lens. Okay, so use that idea along with the solar panel idea, and let me show you what this one company figured out. In fact, they were so successful that these things are showing up everywhere. So the world's largest solar thermal power station at the moment is in Ivanpah. It's the solar electric generating system. And basically it's in the Mojave Desert. It's the middle of nowhere. It's in somewhere that's hot and dry and gets sunlight almost year round. This thing generates almost 400 megawatts of power, and it started operating in 2014, so about 6 years ago. This thing has 173,000 heliostats. Now these are mirrors that track the sun, and each mirror is the size of a garage door. And what they do is they use the mirrors to focus solar energy on one of 3 centralized solar power towers. So they've got like 4,000 acres of public land near the California-Nevada border, and they put all these mirrors to focus the sunlight up on one of 3 receivers. Now they focus the receivers on these. You see it here. There's one in here, and it's about 500 feet tall, and it's full of water. And so they are focusing the power of the sun, all that sunlight here, to heat water. Now, what's really cool is a nuclear power plant will, in 1976, cost like almost $6 billion. That's equivalent to about $25 billion today. This facility that I'm talking about now that's solar powered only cost $2 billion today. So you could make 10 of these, and it's different from a nuclear power plant in that it's the impact is zero, like there's no nuclear waste when we're done, and the fuel is free forever because it runs on sunlight. And its job is to heat up water, and we use that water that's turned into steam to turn the propellers of like a motor shaft, which now we can use because now we have rotational energy, and we can use that for other things. So they can turn that into electrical energy. Okay, there's a one downside to this, right? What's the downside? Okay, so the downside is, how well does this work at night? It doesn't, right? They figured out a way around this, and it comes from using salt. Remember yesterday we looked at how you can store energy in salt? So check this out. The Crescent Dunes Solar Energy Project is a 110 megawatt solar thermal power project, and it generates energy near about 1.1 gigawatts. Now, it's the first utility scale concentrated solar power, a CSP plant that came online about 5 years ago in 2015. And here's how it works. It has a central receiver tower that has a bunch of salt. We're like 70 million pounds of salt. And it's up here. And so what happens is the light from the sun comes down. It's like a giant mirror farm. It comes down, hits these mirrors. You see all these tiny little mirrors, and they're all pointed to the center tower. They melt the 70 million pounds of salt, and it keeps that salt at about 1,000 degrees Fahrenheit, which means the salt will stay in liquid form, melted form, for the lifetime of the plant. The energy in that melted salt is used to heat water to make steam to generate the electricity. So if they have too much energy, they'll actually store that extra energy and use to, and so what they can do is, even when it's nighttime, this thing is still really hot, which means that it can still power and heat up steam all through the night until the sun rises tomorrow morning. So it's really cool. So it doesn't have to like shut down and then start itself up like the power plant I showed you just before. It can keep going throughout the night, and it doesn't have to stop. So it's constant. It's got a constant power source. So by this year, actually, it's been estimated that these power plants will actually, if you use this, if you connect your house to this, you will only pay about 5 cents per kilowatt hour. Today, when I looked at my electric bill, it was about 20 cents per kilowatt hour. Washington currently is the cheapest state at about average of 7 to 8 cents per kilowatt hour. So these guys are going to be even cheaper than the cheapest states now in the United States per kilowatt hour for your electric bill. So what's really neat is, you see this picture here. This is an old strip mine. These are ugly. People don't like them. This is how people get different minerals out of the earth. They're perfect for these types of mirror farms because they're staged, they're already deep in the earth, and then usually they're dug down deep enough where they hit the water table. So now they also have access to the water that they need for this thing to work with the salt, which is heating up water. So these old strip mines are being converted into CSPs, concentrated solar power plants. Isn't that cool? The United States currently has 12 of these operational. Most of them are in California. Spain has 32, and all of them became operational in the past 10 years. Now, the United States has 5 of the largest facilities, and they're all close to about 300 megawatts. So you start to put these things together, suddenly they're generating more power than a nuclear power plant. So isn't this cool? And it's free forever. So it's amazing what you can do with technology, and it didn't take that long to develop. I mean, we've known about this type of, concentrating solar power for a long time, just didn't have this application before. Okay, how are we doing so far? Is this making sense? Okay, so now we're gonna use this idea, this concentrated solar power, to actually bake our cookies. Now, by the way, before I forget, my name is Aurora, Supercharged Science. If you've just joined us, welcome. We're talking about renewable and alternative energy, and we're focusing today, pun intended, on solar power. We're about to bake some solar cookies. Now, I've gotten some parents asking, are we gonna be doing the magnifier experiment? The answer is no. I tell you about that experiment because I want to illustrate you should never look at anything, never look at the sun through anything with lenses. So please, kids, we're not doing that experiment. We don't encourage you to set fire to anything. We like your eyebrows where they are. Today's experiment is on solar, is about using the power of the sun to cook. And this is a really cool application because you can set this up anywhere. Now, even if it's cold and snowy outside, you can still do this experiment. And when the sun comes out, then you can actually bake your cookies. So go ahead and grab a piece of paper, grab a pencil. I'm going to show you a video. It's not very long. It's like 5-6 minutes. And I'm going to give you different distinctions, different variables as we go through the experiment. Write those down. And then when we're done, you can look around you and see what you have that you can use for this experiment. People have done all kinds of interesting and creative things, including using Pringles cans and I think Kleenex boxes. So don't be limited just by the pizza box that I'm showing you. You can use a lot of different things. Okay. Oh, and if you're concerned about contamination with raw eggs, these cookies will get cooked. Use a thermometer. Anything over 165 degrees is fully baked, and E. coli is not an issue. If you are worried about that, use pasteurized eggs or just leave the eggs out completely. The cookies will still taste amazing. Anything with chocolate in it, I mean, you just put more fat and more sugar in it, it'll just taste great. Okay, so let's go ahead and get started. You don't need your cookie dough yet. We have to build the oven first, okay? So I'm gonna show you how to make an oven, and then if you're still interested, I will show you a second oven or something else you can add to your oven to make it work even better if you want. Or if you're satisfied with that one, you can just leave it as phase one. But I actually have two projects for you today. So we have solar cookies part 1 and solar cookies part 2. Okay, ready? So grab a piece of paper. Let me get that video ready for you. And let's get going. Here we go. We're going to learn how to cook using our own solar oven. Now, in order to make a pizza box cookie baker, you're going to need some aluminum foil, also some saran wrap, some tape, and sharp scissors or a razor. You'll also need some black construction paper and a pizza box. Let me show you what you need to do to get started. Now you want to measure over about 1 inch, and you want to cut out on 3 sides a door of your pizza box, okay? You might want to lightly score it on the 4th side so it's easier for you to bend it open, just like that. Now you want to cover this side here with aluminum foil. Go ahead and use some tape. You don't want to use hot glue because it'll melt when your oven gets warm enough. Go ahead and use some tape and secure some foil to this side. So how this is going to work is sunlight is going to hit your aluminum foil, and you're going to position it just at the right angle so that the light, most of the light that hits your panel here, gets reflected into your box. So we want to have a transparent cover here that will allow light to pass through, but it will trap heat inside your box. To do that, you want to cover this with a thin layer of plastic wrap. Okay, just like this. And you can tape it on either this side or the other side. Okay. So you should have foil on this side and saran wrap here. Now we need to work on the inside of your oven. If you have a piece of tissue in here, go ahead and take it out. Now the energy that comes into your box, it's going to be trapped here, and we want it to absorb as much of the heat as possible, and we want to make sure that that heat not only gets put here, but it stays here. And there's a few different ways to do that. We're going to line the box with some black construction paper, and that will help with absorbing the energy, but the paper itself is going to get hot, and so a lot of the energy is going to start to transfer from the paper through the box and actually leak out the sides of the box. So there's a few different ways you can deal with that. One of the things you can do is line the bottom of your box with aluminum foil first, and this will help keep the heat inside your box by putting it back on the paper. The other thing you can do is you can put an insulation layer here as well. So anything like a layer of cotton balls, or if you have shredded paper, you can spread that in here as well. And that will provide an insulating layer so the heat doesn't escape out your box. So I'm going to cover the bottom of my box with a thin layer of shredded paper. Okay, this is going to be like a little insulating layer for me. And then on top of that, I'm going to put my foil, and then on top of the foil goes my black construction paper. Okay. And you can secure this all into place with tape if you like. Okay, just like that. Go ahead and check to make sure that your box still closes, and if it doesn't, go ahead and make adjustments so that works. Now your last step is to actually put something in here to cook. You can start out with something simple like a graham cracker with a marshmallow on it and maybe a piece of chocolate, kind of make your own s'mores, kind of melt them all together. Or if you want to go a little bit trickier, a little bit more advanced, go ahead and plop a couple of drops of cookie dough inside and you can expect your cookies to be ready in about 4 to 6 hours. Now, a neat addition to this is a thermometer. So if you happen to have one, go ahead and grab it and just lay it inside if you have the kind that's got a wire attached to it. This way you can monitor the temperature inside, and you can kind of get a feel for how hot or how cool your solar oven is. Now, a few things that are going to affect it, of course, is the insulating layer, the paper underneath here that we talked about already. And also what's going to affect it is the size of your pizza box. Other things that are going to affect it is the angle that your panel here is going to make with the sun. Go ahead and put something in here and we'll talk about that next. Now, the last step is to actually adjust your panel here so that you get the most amount of light reflecting from the sun into your box. Now, this is going to depend a lot on where the sun is at the moment, and you may have to move this as you go along. You may have to help your box track the sun as it moves across the sky. So what you want to do is place this in a dark room, use a flashlight, and shine the flashlight, have it in a position where the sun is approximately right now, and then you'll be able to see where most of the sunlight is going to be inside your box, okay, and kind of get a feel for this. There's you can also use a laser beam if that would help you more. The laser isn't going to reflect very well off of a wrinkled surface, so make sure you get a nice smooth surface here. Another neat addition is to add a protractor to your pizza box. I've got one that I've printed out here on a sheet of paper, and by taping it to my box such that the 90-degree mark here, okay, is right where the hinge is. So this would be my 90 degrees, this would be different angles. So when I'm inside the house and measuring at what angle this needs to be at to get the light in here, I can easily repeat that when I go back outside. Okay, so you can simply use a piece of tape and tape that into place, and that will help you as well. Now, your pizza box should get around 200 degrees, but depending on how well it's insulated and all the other factors that we have already mentioned, it may vary a bit, which is why having a thermometer inside is a good way to actually write down your measurements as you go along. Go ahead. All right, so what'd you think? Is that a project you can do? Somebody said 6 hours for cookies, but if you start them in the morning, they'll be ready just for after lunch, right? Yum. Okay, so did that make sense of what we're doing? So there's a few variables that it's going to change and affect how well this works or doesn't work. So if it's more insulated, if you're thinking, hey, maybe I could stick that thing in a cooler and put the thing on top, that's foam you could put all around, that would be great, especially if you've got snow on the ground. You want a good insulating layer. You can also build it out of the Pringles box because they're already shiny and silver on the inside box. It's like a round tube. You could try something metallic, maybe like a soda can, and you just have one tiny little cookie in there. And then you have to insulate because metal is actually a really good conductor of heat, so you want to make sure you wrap it in something in order to insulate so it'll work even better. So there's a lot of cool things. By the way, if you're going to do a soda can, please be careful. Those just thinking about the sharp edges that's going to make, maybe that's a bad idea. Okay, so how are we doing so far? Does that make sense? Okay, so we have a couple of questions come in. One of them was, does the cookie dough go straight on the black construction paper, or do you put another layer of foil? So what you can do is you can put a small layer of parchment underneath, so you're not baking directly onto the black construction paper, so none of the dye will come up into your cookie. So you can just put a tiny circle of parchment, and then it'll be sure to transfer that energy to the bottom of the cookie. Can you do more than one cookie at once? Yes, absolutely. As many as will fit in there. Remember, every plop you put in there is a thermal mass though. So initially it's going to take longer to heat all that up. Another question, it's currently 65 degrees. I don't think that's warm enough. It's perfect because we're going for light energy coming in. We're not relying on the ambient temperature around you. I'm going to use some sense if it's 30 below. This is not a good day to do this experiment. So you can also insulate it. You can lift it up off the ground, put it on a layer of blankets or towels, or you can use a layer of foam, something to just get it up and off the ground so that doesn't influence it if the ground is really cold. What cookies bake the fastest? That's an excellent question. So you guys are real scientists. having questions like this are fantastic. How many different types of little ovens can you make? And you can time it, get them all out there at the same time, and see which ones work best. What can you use if you don't have construction paper? You can use anything that's dark, anything black. So you ever been in like shorts on a hot summer day and somebody has like black car seats? Yeah, what happens to the back of your legs, right? Ow! That wasn't black construction paper. It's just the color tends to hang on to that infrared heat, that heat energy. Much more than the white reflective sources. So the white, if you have a car with black seats and a car with white seats, the car with white seats are going to not burn the back of your legs nearly as much as the black ones. So just get something dark in there. I don't recommend spray painting because you're going to be cooking something that you're going to eat. So you want to have something that's already black and something like black construction paper or a black piece of plastic or something that you have that's dark. You could even have a black towel in there. Okay, can we do more than cookies? Absolutely. You can use it for all kinds of things. What kind of things can you bake? Now remember, this, you want to put a thermometer in there so you can kind of get a good sense for what temperature that particular oven can heat to. And depending on the layer, you can even use 2 or 3 layers of the saran wrap on top to make sure you really do trap it in there. Or if you have also other forms of clear plastic, you can try those as well. Ones that are a little bit thicker will may work better. You can try that. Could you make cupcakes? I don't know. Try it. I would try the small mini cupcakes initially. If you've ever noticed, when I was a student, I couldn't afford a muffin pan, and so I would just take the cupcake liners and put them on a cookie sheet because that's all I had, and they worked great. So you can just put a cupcake liner with a little bit of something in there. I bet you can get really creative. Can you use black Legos? You can certainly try it. You want to make sure you're not going to melt your Legos, but definitely give that a try. So, okay. Would you like to see part 2? What do you think? Do you want to see the second thing you can do to make this work even better, or a slightly different design? Are you interested in that? Tell me what you think. So while you're telling me what you think, let me see if I've answered all the questions that have come in here. Other questions that have come in, what kind of cookies are your favorite? I like chocolate chips with walnuts in it, but I'm just partial that way. I also like cookies that have been dipped in chocolate. So as you can tell, there's kind of a chocolate theme going on here. Okay, let me see. What other questions? Will these work without eggs? Yes, I have made the cookies in there without eggs and they work just fine. The eggs are a binder. It'll tend to hold the cookie together even more. But you know, for this experiment, will you miss it? Probably not. Okay, fish. Could you cook fish? I would tend to use my barbecue for fish because I don't like the smell of fish. I mean, it'll tend to stink things up, but that's just me. Let's see. Okay. All right. So hang on. This is a video that is, let me see how long this video is. This one's like 3 minutes long, maybe 4. I can't tell. Okay. So here we go. You want to take a look at part 2? Here we go. Ready, set. If you've made the pizza box cooker, you know there are 2 ways for the energy to enter into your box. It can either be reflected off the back panel or it can simply go straight into your box. Now, what if we make this panel larger? Like, say, 4, 5, 6, even 10 times larger, and instead of just having a flat panel, we make it more round, like an ice cream cone, and it focuses and concentrates that energy all into your box. That's what we're going to make right now. Let me show you what you need. You're going to need just about the same things as you did for your pizza box cooker, only in addition to the black construction paper, the pizza box, the cling wrap, the aluminum foil, and the razor, as well as the tape, you're also going to need something to make a funnel out of. Okay, so if you have thin cardboard or poster board, that's going to work really well. Let's see what's involved with making this kind of cooker. The first thing you need to prepare is your pizza box. Now, because we're going to be making a cone, you can actually cut a round or a square shape, whichever one is more comfortable for you to work with. Okay? And you're going to be using a smaller pizza box than we did before. Okay? And you want to go ahead and cut it on all 4 sides. Okay? Go ahead and open up your pizza box, and what we're going to do now is line it with either an insulating layer, if you're doing that, either cotton or paper, something that will help insulate the bottom and not have the heat transfer out of your cardboard box. Okay? Or if you prefer, just go ahead and line the bottom with aluminum foil. After your tin foil layer, you want to go ahead and place black construction paper right on top. Okay? So go ahead and cut your paper to size, okay, and lay it inside. Now our next task is to cover this with our saran wrap. So go ahead and do that now. So your oven part is complete. Go ahead and fold it up and make sure everything fits together. Okay? And it does. Now, you can go ahead and place a little bit of food in there if you want, if you have like a marshmallow or a piece of chocolate, so you can test this out. Place your food inside and close the box. Now we need to make the reflector part of your cooker. Okay? Take a large sheet of poster board and cover the entire side with aluminum foil. Go ahead and curl it into a cone shape. Okay? And when you've got the shape that you want, go ahead and tape it into place. You might want to double check it with the size of your opening here. Okay? Once you have your cone made, go ahead and get in there and smooth out all the wrinkles you can. Now I've actually made a narrow cone. Your cone can be a wide or fat or whatever shape you like. It might be interesting to see what the different shapes can give you. Okay? Now your last step is to attach the two together. Now you can do this in a number of ways. You can use tape to tape this cone section straight to your pizza box, or you can simply prop this up somehow next to a chair so that it's easily removable and you can get to your food inside. Go ahead and find the best way that you can find to secure these two together. Once they're secure, you want to place them outside, aim this at the sun, and stick a thermometer inside so you can also measure the temperature as you go. Go ahead and give that a try. So what do you think about that design? Does that seem like something you could add on to a second or third iteration? Pretty cool, huh? So there was one more thing I wanted to share with you. If you still have enough gas with me to keep going, you want to do a little bit more? I meant to show you something before and I just forgot. It happens because I get really excited about what we're doing. So I wanted to show you how the solar, oh, I wonder if I can even find it. Oh, here it is. I found it. Okay, I wanted to show you specifically how the solar thermal power stations, the CSPs, work because I'm getting a lot of questions. You can also just type in your questions. I'm getting questions by email, but go ahead and type your questions into the comment box so I can answer those. Let me just show you something really cool about how this project we're doing with the cookies is similar to the salt project that I showed you before that is used to generate electricity from the sun. Watch this. Okay, you see it here? Let me start it at the beginning. Okay, so remember we talked about the solar thermal power stations, these guys here. Okay, so most people think that solar power stations are just solar panels, like remember the two guys in the beginning? This is what most people think of when they think of solar power, but there's actually a whole nother science and technology to it. And as I mentioned before, solar panels are really expensive. So these CSPs, they capture the sunlight and they create heat using curved parabolic mirrors. All that sunlight is directed and concentrated onto a single focal point, which is a cylinder, a pipe, filled with synthetic oil, and it travels through the row of mirrors, picking up heat as it goes along, and it heats that oil up to about 400 degrees Celsius. And then it goes into something called a heat exchanger, where the hot oil will heat the water into steam, and that steam will then push a propeller, it will drive a turbine, just like a traditional power plant does. Now this company made massive solar fields. Oh, did you see all that white stuff at the end? They made massive solar fields. This stuff is actually water vapor coming out. It looks like pollution, but it's actually hot steam, not pollution coming out of the end. So this is just excess energy that was coming out. And this was part of something from National Geographic, so you can look that up as well. Okay, so that's basically what you're doing here, only instead of the pipes of oil that like the big factories are using, you're just putting it into something that you can eat. Okay, so I think we should stop because we've done a lot of content for today. Kids, you've got a number of things to do. We are, I have a couple quick announcements before you leave. So I want to see pictures of you doing your projects. Please feel free to send them to me. Let me know if I have permission to post them. If not, I'll just look at them, grin, and say, great job. And I'd love to see them either way. You can email them to Aurora at superchargedscience.com. We have 2 new things that are coming out that we haven't released yet. The first one is our summer science camp is open for registration. And so you can take a look here. I will show you in just a minute. If you want to stay with me, I will show you what it looks like. And you can go to this link here to find out more about it and find out what's involved and the cost, and which is way cheaper than you can imagine because it's only per household. So all the members, all the kids in your family can go just for the price of one. So it'll be really, really fun. So it's a summer science camp your kids can do. Your house will turn into a summer science, it'll turn into like a science museum. I apologize now what's going to happen to your Tupperware as well as your hair dryer. So your kids are going to be making wind tunnels and all kinds of go-karts and all kinds of stuff. So that's the first announcement. The second announcement is Supercharged Science is going to be holding a science fair. What does that mean? That means that all the projects we've been doing, we've done 7 weeks of projects. So all the projects we've been doing is just step 1. If you'd like to participate, everyone, in order to participate, you're going to register. I'll give you that link tomorrow. If you want to, when you register, then you're eligible to win a prize. And so we'll have a grand prize, and we'll also have a prize for everyone that completes a project. So you'll register so you have your spot in the science fair, and then you'll have, I'll give you the criteria and what's required. And then at the end, when you turn it in, you'll win a prize. And then we also have one prize available for our grand prize winner. So I will give you all the information. So if you did the bridges, if you did the engineering, the skyscraper projects, it'll be very similar, only I'm going to teach you what a science fair project is and what it is not. Hint, hint, hint. So when you go back into public school, or whether you go back to your homeschool or your private school or whatever school you went to, next year you will know exactly what to do for a science fair to really blow away the competition. I mean, just we have a number of science fair projects we've done over the years, but this will be your opportunity to show me that you can do a science fair project. And if you have no idea how to do one, it's okay. I'm going to walk you step by step and show you exactly what you need to do in order to complete this. Now, the idea is going to be yours. Whatever the idea is, it's totally fine. I'm going to tell you the steps you need to complete for it to be a science fair project, not a research project, which is a totally different animal. So if you're interested, that we're going to release that tomorrow during tomorrow's class. And so the science fair project. So if you're interested in that, make sure you tune in tomorrow at 10 a.m. Pacific. Let your friends know as well. There's no cost. You just have to register so we can send you that packet of information, okay, of what to do and what's required, that sort of thing. So that will be coming out tomorrow. Today we are releasing our summer science camp. Registration is open, and there's a limit to how many people we take, so I'm just telling you this now. The first year we ever offered this, like 10 years ago, we were amazed that we had over 800 people sign up in like 4 days. So and that was 10 years ago. So that's the first time we did it. So let me show you what my summer science camp looks like, and then you can decide for yourself if it's something you'd like to learn more about. So let me find it here. Let's see here. Give me just a second to pull it up. So I'm so excited. We have so many fun and interesting things to do. And yeah, you can participate in our science fair no matter where you are in the world. Again, there's no cost for this. So your kids will be engaged. You'll have a couple of weeks to work on this. It'll be due the last week of May, because starting in June, that's when we do summer camp. Okay, so do you have to register if you're already eScience members? No. So if you're an eScience member, if you're a member of my online science program, the one that's a monthly or an annual membership program, you get eCamp for free. Yay! And there's no cost. We will have to sign up for the science fair project, but that's free as well. And you can use any of the resources on my online summer camp as well, or summer program. Okay, is the science camp online? Yes, the whole thing is online, just like we're doing now. Every day, well, here, let me just show it to you. Every day your kids will log on, and they will be able to participate oh, I forgot to tell you about the first cookie that was ever made in space. It was baked back in January. It's the first food baked in space by astronauts. They made one chocolate chip cookie. Look at that. And the first thing my kids asked when they had this special oven they put in, this is the first cookie ever made in outer space just a few months ago. My kids said, well, how did it taste? And the answer is, they don't know. They cooked it, they did a bunch of tests on it, but nobody actually ate it. I don't know, what is wrong with these scientists? I would have made two, one for the experiments and all the data, and the second one for me. Okay, all right, let me show you the science learning space. Okay, here we go. Let me log in here, and then I will share my screen with you. Okay, so for summer camp, it looks like this. I have full access to everything, and so you'll be able to actually see what it looks like, even though it hasn't been released yet. And this is open to anyone, so you don't have to be an online, you don't have to be a member of my online program. You can just get summer camp. If you're already a member, we give you summer camp for free, so you don't have to pay for it, okay? We've never done projects yet. Is there an age range? Christy, yes, there is an age range. It's kindergarten all the way up to about 8th grade for the lower level, and all the way up to 12th grade for the upper level. And when you get the upper level, we give you the lower level for free. So if you've got kids like I do, 1st grade, 4th grade, 9th grade, 12th grade, get the whole thing, and then you'll have access, get the upper level, and then you'll have the whole thing. Okay, they need a baker's dozen. Yes, that's true, Brooke. Okay, science camp is all online, and you'll find it here. So you will, this is the online science program, and so you'll simply go here and you go to science camp, and you'll click on that, and then it's open June 1st through August 31st, and attention, if you're a member of the program, you'll get it for free, and it stays open through November 1st. So these projects are above and beyond what's available online in the eScience camp. Whoops, sorry. There's me teaching science camp for real. So I had a camera crew following me, and those videos are posted. So it'll be just like I'm there with you doing summer camp, because I'm actually teaching hundreds of kids science camp, which is really fun. Okay. And so we're introducing all kinds of topics. So let me show you what kids will do. So they'll click to access summer camp, and then you will be taken to a page, and it'll have all the labs here. Now these are all gateways into other sections. So you will have information on how to get started. There will be complete shopping lists. And then you will have flight labs along with the release date. So we stagger it out because it's kind of like drinking from a fire hose. There's a ton of content on here. So in June, you'll have access to the first 4 labs. We have flight, kites, rocketry, and robots. Oh, I'm sorry, flight, kites, rocketry, and it should be astronomy. Whoops, astronomy is in the wrong place. We're gonna have to change that. And astronomy, that's in June. And then the next one is electricity, robots, and physics and lasers. And then the last set is chemistry and the spy science lab. So this is forensics, that kind of thing. So those will be released in August. So every month a new set of experiments will come out, and your kids will go through it just like we're doing today with Facebook Live, where I give them some content and then experiments they can do, and content and experiments they can do. And so the content is less academic and it's more based on hands-on. So let me show you the advanced eCamp, just for those of you with high school kids. Other questions? They wouldn't even try the cookies, I know. What date does summer camp start, Sham? It starts on June 1st, and it turns out, here, let me grab the advanced camp. Other questions? I'm so excited to make solar cookies. I know, yay! Tell me how they taste. I want to know. I want to see a picture of your oven and then your kids eating it and then telling me how they taste. Then let me know if they got the sugar and the salt mixed up, because that's another chemistry experiment as well. Let's see, let me type here. Let me show you the advanced camp. Let me type in advanced so it comes right up. What time does camp? Oh, it starts on June 1st. And so when it's 8 a.m. or midnight on June 1st, that's when camp opens, and it's open all the way to August 31st. And so it's got new content that comes out every month. So let me show you the advanced summer camp, and it is right here. Because if you've got older kids, you know that you need a little bit more involved projects projects that were more involved to keep them interested and excited. These are the ones for advanced kids. They're going to fly real rockets. They're going to make alien detectors. They're going to make robot projects, laser light shows, space age laser communicators where they ride music on a beam of light, which is really the backwards technology of, okay, so quick science lesson. So if I'm talking, there are sound waves, right? So those sound waves are hitting things and making them vibrate just a teeny bit. If I'm talking inside of a house and I can actually look at the window and it'll vibrate just a teeny bit in response to the sound waves, I can hit that window from the outside of the house with a laser beam, have it bounce off. Some of it will go through and some will reflect back. If I can catch that reflection, it has that information of the wave of the window shaking just a little bit due to the sound waves from my mouth. And then I can pick that up and actually hear the conversation going on inside the house. Isn't that cool? Okay. Technology is my job. Ethics are your job. Okay, so so that's the space age laser communicator, the underwater ROV robot. This is a project. Actually, here, let me just show it to you. It looks like this. This is the underwater ROV. It'll work. This is the black stuff is the PVC pipe from a hardware store, and we use a soap dispenser. A soap box for the controls, and we actually show you how to wire up the whole thing and waterproof the motors and everything. Let's see, we have other things in here. We have learning how to solder. We have police sirens and doorknob touch alarms, crystal radios. We have the beam bots, which are super cool. Those are the robots I demoed last week where you take apart old cell phones and you add a solar panel and you make these teeny little robots that go with the power of the sun. Those are in there as well. Potato cannons, we have advanced electronics and Arduino robotics, and we have go-karts, which are super fun. So those are the advanced projects. So again, if you've got older kids, those are great. Or if you've got a dad or that's handy or a mom that's handy and you want weekend projects, these are perfect because they're gonna take them longer to do. Okay, so that's the advanced program. Okay, so other questions that are coming in. When does summer camp? Okay, so camp goes here. Let me put the dates up here so you can actually see it. So there are different labs. So there's about, I want to say between 250 and 300 science projects, and it's open June 1st through August 31st. Do you see that? You can just get science camp and you can do that, or you can get, if you're a member of our online program already, then it's already included. You don't have to pay for it and you get it for longer through November 1st, okay? So as soon as you, so if you are interested in this, it's got a full 30-day money-back guarantee that starts June 1st. So if you register today, you'll actually have through June 30th to try the program out. It's got a full unconditional happiness guarantee. Try it, see if you like it. If you don't like it, just let me know by June 30th. Don't wait till the end of summer and say, hey, that didn't work. That doesn't count. So it's got a money back guarantee from the first 30 days that you have access to it. And you will get your login today as soon as you register. So you want to use that link that's at the bottom. And then you can access the activities through eScience when it opens on June 1st. Now, again, this registration is only open today. It's gonna close today at 6 p.m. So we're only opening it for one day, just to see if there's anybody interested in this program. And if so, then we'll open it up later, maybe, depending on how full that it gets right now. If you register today, you'll also get early access to some of the activities. We're going to actually start eCamp a little bit sooner, just for you, just in case you'd like to start these projects a little sooner. We will actually go ahead and do that for you as well as a bonus. So yay! So you get, again, just to recap, you'll get, if you get the older version, the older kid version, you will get the access to the younger, and then you will also get all of the kids in your household for the price of one, unconditional happiness guarantee, and we will release some of the activities a little bit early just for you. So there is a video that will describe all of this, and so you can use that link down there. Okay, the cookies were great. Oh, you've already made them. Oh my goodness. Let's see, I loved everything. Where would you find the advanced camp link? It's the same link. So you would go to this link and you would choose the advanced or the standard. So we call it standard is K through 8. Advanced is 9 through 12 plus K through 8. So both of those are at the same link right there. They will be Will these fabulous classes be stopping for during science camp? Oh, you're asking what our Facebook Lives will be doing. I'm not sure, to tell you the truth. We've been doing this for 7 weeks, so I'm not sure how things will change. It depends on what people really want. So we will see what we do. I love being able to do these every day. And I also know that some people have said, you're doing too much. I'm overloaded. I can't use everything. So I'm not sure. We do plan on changing things for the summer because summer is a different time for our family. And so I'm not exactly sure what we're going to be doing yet, but you will be the first to know. Does the really big box work? Oh, for the solar cookie project. So I would try different sizes of boxes. The bigger box has more volume of air. So going back to the solar cookies project, so it's going to take longer to come to temperature. So I would try small, medium, large. And I don't know if you figured it out yet, but you can also just put you can put the cookie dough in a Ziploc bag and stick it in there. And so that will also make the compartment of air smaller and concentrate the energy even more, right? Because we did several different layers of insulation, and this is yet an even, it'll keep that air really packed tightly around your object. So you can use big freezer Ziplocs, small Ziplocs, sandwich Ziplocs. Okay, I want these to never stop. Just call me the Energizer Aurora. Okay, if you have any more questions, please do let me know. Aurora@superchargedscience.com. And let's see, would a 7 times, yes, actually, the question was, will a Fresnel lens work? Yes, this is actually a 7 by 10 inch, and so this is going to work just fine. You'll see me tomorrow put it in the box. So just make sure you have this and a box that's a little bit bigger, and it should work just fine. You can even use the little teeny ones, but the business card size, if that's all you have, just use it. Okay, other questions? Thank you everyone for your kind words. If you're going to try summer camp, go ahead and you can click that link or put that link in now. It looks like camp registration, it says, is only, this is from my staff, they're only open today. We are going to close it at 6 p.m. So make sure you check that out. Send it to anybody who's interested, just so they can watch the video and find out more about it and see if it's something they want to do. So thank you so much for sharing your time with me. I hope you've enjoyed this class. I will be announcing the science fair tomorrow. So be on the look for that. I will see you tomorrow on Facebook Live at 10 a.m. Pacific. Take care, everybody, and go enjoy your cookies.